All right, welcome. This is chapter 8.2, the ellipse. So let's kind of go over a definition and we'll draw a picture of what an ellipse is. So an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points is constant. Okay, so we have two fixed points, and these two fixed points are called foci. So foci. I'll kind of color coordinate this so you can see. Okay, so blue is foci. And then we'll draw our actual ellipse in black here. Okay. So what the definition basically means is that these 2 points, and if I take the distance from this point and this point to the ellipse, if I add those two together, I get a constant. Okay. So a line segment through the foci called the major axis intersects with the ellipse vertice. Okay, so this purple line here will be the major axis. And then this point here and this point here we'll call the major vertices or vertex. So this point right here, the midpoint of the major axis is called the center. You have a line perpendicular to the major axis that goes through the center. It's called the minor axis. And then you have 2 points that intersect with the ellipse called the minor vertices or minor vertex. Okay. Now there's a couple other measurements on this that we want to know. So let me just get this here. So if I take the distance from here to here and here to here, if I add those two together, okay, if I take D1 plus D2, I get my entire string that I used, or I get some constant. And you can go anywhere on this ellipse and add those together. So this is D3, D4. So if I take D3 plus D4, I get the same constant. I just get however long that is. So there's a couple other measurements we want to know, and we will label those A, B, and C. Okay, so A is the distance from your center to your major, and I'll use a capital M for major, vertex. Okay, so I'm just going to draw a new one down here. Okay, so I've got a foci. Okay, and my center, which is, so from the center to the major vertex right there, that is A. Then we'll go to C. C is the distance from center to foci. So we'll use purple for that. And B is the distance from center to your minor vertex. Okay, so how about blue? Now this creates a right angle right here. And in fact, this distance right here is also important. That is also A. Okay, so we'll be using the Pythagorean theorem to maybe find out A, to find out C, B, any of those. So make sure you remember the Pythagorean theorem. Now, one of the main questions I have with this is, how do I know which way the ellipse will open up? Well, you'll have a handout with you, kind of like we did with the parabola, but there are two types of an ellipse. Okay, there's one with your major axis running horizontally, and the other one has the major axis running vertically. Now, the thing is A goes with your major axis. So when we look at the equation here, since that is the x-axis, then A will need to go with your x value. Here, your major axis runs with the y direction, so A, in that case, will need to be with the y. So you'll have your worksheet that looks like this. So again, the top portion of this worksheet, is that focus? Again, the top portion of your worksheet will deal when it is centered at 0, 0. And then you'll also have the second portion, which will look like that, which is when the ellipse is centered anywhere other than the origin. So we really want to look at this one right here. So let's write those two equations. Let's write those equations down. Okay, so you still have h and k. So in this case, we'll have x minus h squared over a squared. And since the x and a go the same direction, or the a needs to go on the x, plus, since it's the sum of the two, since up here we talked about the sum of the two distance, y minus k squared over b squared equals 1. And then this one's very similar, except a and b switch spots. So this one will be x minus h squared over b squared, since the minor b goes with the minor axis, so it goes in the x direction, plus y minus k squared over a squared equals 1. Okay, so I kind of have a little bit, maybe a better drawing here of what's going on. So if your ellipse major axis goes vertically, okay, your a is going to go with your y. Now a is the distance from your center to your major. B is the distance from your center to your minor. And then C is the distance to your foci. So this distance right here. Okay, and we will find that using this principle right here. Okay, that c squared plus b squared equals a squared. So a lot of times you'll have a and b. So to find c squared, you are going to want a squared minus b squared, and then the square root of that. So this right here is going to be pretty important for you to know and to understand. Okay, the other thing we have with an ellipse is called the eccentricity. Let me write that down for you. And the eccentricity is just how circular or how flat your ellipse is. So I might have an ellipse that looks like this, or I might have an ellipse that looks like this. Okay, so they are very different in their eccentricity. The eccentricity goes between 0 and 1. Okay, if it is a 0, it is more round, like a circle. As it goes to a 1, it's a flat or more linear. So it looks like a line, okay? So 0 is an O or a circle, 1 is a line, just kind of how it seems. How do I find the eccentricity? So that is E equals C over A. Okay, and you're gonna want that equation. Okay, and again, that just tells us how round or how flat our ellipse is. So let's try a question here real quick. Okay, so I want to graph x squared over 25 plus y squared over 9 equals 1. Okay, so I need to get everything to be squared. So I'm going to rewrite this, and we will say x squared over 5 squared plus y squared over 3 squared equals 1. Okay, since 5 is bigger than 3, A is going to be 5, B is going to be 3. A is always your bigger number. And since A is with X, that means my ellipse is going to be longer in the X direction. Okay? So from the center, and because there's no H and K, okay, H and K moves it left or right. Since there's no H and K at the top, it's centered at 0, 0. So in fact, 5, 3, so this is 5. So this distance right here is 5. So this point is 5, 0. This point here is 0, 3. And then you just have the negatives. So negative 5, 0, and 0 minus 3. Okay. And that's it. You got to know that this distance is 5, which is A. This distance is 3, which is B. I could find Z, or I can find C. C squared equals B squared minus A squared. Okay, which is what we just had on the flip side of this paper. C squared is A squared minus B squared. Okay. So then we'll just plug it in. So B squared is 9 minus A squared is 25, and then the square root. And it'll always be the positive number. I must have mixed those numbers around. So 25 minus 9. 16. So C is 4. Okay, so the distance from the center to your foci is 4. So this foci is at negative 4, 0. And this one over here is at 4, 0. So I want to see those on your graph when you're graphing them. So eccentricity, which was the E, so E equals C over A, which is 4 over 5. So 4/5. That's pretty close to 1 here. So we know that this is pretty strung out here. Okay, it's much more linear. Okay, so let's rewrite this C. Yeah, A squared minus B squared. Yeah, that's what it needs to be. A squared minus B squared. I did B squared minus A squared, so I should have flipped those around. Okay, so here are your suggested problems. So pause it. You can write those suggested problems down. That way you have them. You will need those for class. Okay, come to class with those. And then your questions are, what is the general equation for an ellipse whose major axis is vertical? Okay, so what's the general equation for an ellipse whose major axis is vertical? Number 2, sketch an ellipse and label the following. You're going to label the foci, major and minor axis, A, B, and C, major and minor vertices. And then you are going to sketch the graph. You're going to sketch the graph for this. Oop, this is a Y. That's an X. So sketch a graph for this. Y squared over 16 plus X squared over 4 equals 1. And those are your 3 questions. Come to class with them. If you got questions, please let me know. If you're going to be gone, you need to watch the lesson video that will be linked right here. Okay, right here. Click on it, watch the lesson video. You'll be good to go. If you need a copy of the handout, I will link it below in the description. Okay, as always, thank you so much for watching. Like, subscribe, comment below. At THS, Mr. Jones, signing off.